An ant climbs, bites a leaf, and stops moving. A few days later, a stalk erupts from its head. What just happened? Meet Cordyceps. More precisely, Ophiocordyceps, a group of parasitic fungi famous for turning insects into what we call zombies. It isn't a mind reader or a tiny puppeteer sitting inside the brain. It's more like a patient engineer. It creeps through the body, wraps itself around muscles and organs, and pushes the host to perform one last, perfect behavior. Climb, clamp, and become a launch platform for the next generation. If nature had a horror director, evolution would be it. The story begins as a microscopic spore drifts down through rainforest air and lands on an ant's armor. That shell, the cuticle, is tough, but the spore carries enzymes and a germ tube that probes for weak spots, a joint, a seam, a pore. Think of a locksmith testing every key on a ring. Once a match is found, the tube slips through, and inside the ant, a new map comes to life. Slender fungal threads, hyphae, explore the tunnels between tissues. Careful not to trip alarms it can't silence. From the outside, the ant looks fine. Tidy antennae, busy steps, no drama. Hyphae branch and braid, building a hidden network that winds along muscle fibers like ivy on a fence. The fungus doesn't want to wreck the machinery. Not yet. It needs its host to walk, climb, and place itself. So it sips nutrients, dodges defenses, and releases a cocktail of chemical cues that nudge physiology. A little less sensitivity to colony sense, a little more restlessness, a shift in the timing of activity. To us, it looks like nothing. Inside, the board is being set. Here's the unsettling twist. Dissections show the fungus tends to spare the brain while wrapping and infiltrating muscles. That suggests a different strategy. Hijack the wiring rather than rewriting the software. Imagine steering a robot by tugging on its cables instead of hacking its operating system. The ant's leg muscles misfire, tiny postural reflexes trigger at the wrong time, and its internal compass drifts just enough that familiar trails feel less compulsory. The result is a slow pivot from routine to odd choices. The ant wanders off the main chemical highway, pauses more, and begins to climb. Climbing matters. Higher on a plant, the air is usually warmer and wetter, a microclimate sweet spot for fungi. The time of day matters too. Many infected ants make their final move when light and humidity hit particular ranges. The fungus isn't checking a watch. It responds to the same environmental signals the host can sense and uses those signals to time the finale. At the appointed moment, the ant crawls to the underside of a leaf or a slender twig and bites down on the midrib, the tough central vein. This death grip is not a polite hold. The jaw muscles clamp and lock, and a stiffening of the legs pins the body like a rock climber clipping into an anchor. Underside placement helps. It shields the fungus from direct sun and rain, and it positions the eventual spore shower over the forest floor where other ants travel. The host is now a platform, and a timer is running. With the host immobilized, the fungus finishes its conversion. Hyphae knit into dense tissue and reinforce the ant from the inside, turning the exoskeleton into scaffolding. From the back of the head, a stalk pushes outward. At its tip forms a capsule, a tiny pressure vessel where future spores mature. The stalk lengthens. The capsule darkens. The ant's body, once a worker for its colony, has been repurposed into a greenhouse for a different species entirely. When conditions are right, still air, generous humidity, the capsule opens. A microscopic snowstorm drifts downward, countless spores riding invisible currents. Ants are social and predictable. They reuse the same paths, pass beneath the same leaves, and keep each other clean. That's perfect for a parasite. A few spores land, a few stick. Somewhere below, a new story begins. But this isn't a one-sided horror. Ant societies fight back. Workers groom each other to brush off spores before they can germinate, a social version of washing your hands. Undertaker ants carry suspicious bodies far from the nest. Waste piles and graveyards keep risk contained. Even traffic patterns change to avoid danger zones. It's an arms race in miniature, behavior and teamwork versus chemistry and growth. Cordyceps is a nickname for a constellation of species. Many are picky. One targets certain ants, another prefers caterpillars or spiders. Each species carries a playbook tuned to its host: which plant to climb, how high to stop, which side of a leaf vein to bite. The microclimate bullseye matters so much that a few centimeters can be the difference between a fungus that thrives and one that fails. That precision is why the parasite's choreography looks so eerie. It's been rehearsed for millennia. Could this fungus leap from insects to people? No! Insect-infecting Ophiocordyceps are adapted to small, cold-blooded hosts with exoskeletons and very different body chemistry. Our warm internal temperatures, immune defenses, and cell biology are the wrong playground. Zombie apocalypses make great TV. The real science is stranger and safer than fiction. Why do researchers care about cordyceps? Because fungi are master chemists. They make molecules that help them compete, communicate, or manipulate other organisms. Some of these compounds are interesting in the lab, tools to study cells or inspiration for future medicines. But a purified compound in experiments isn't the same thing as a raw mushroom or an over-the-counter supplement, and natural never guarantees safe or effective. Curiosity is good. Caution is wise. So let's return to our ant on the leaf. A spore rode the breeze, found a seam, and slipped inside. A hidden network grew around the muscles, slowly tilting behavior toward a high, humid perch. The jaws locked. A stalk erupted. Spores fell like dust and the forest carried them onward. It's brutal, precise, and astonishing. Evolution composing choreography one tiny step at a time. What other living mysteries should we decode next? Drop your strangest questions in the comments and subscribe for weekly answers you can explain at dinner. If this blew your mind, share it with someone who loves weird nature.